First guy, Democritus. Greek philosopher, proposed the existence of atoms, small, indivisible particles. Okay? He coined the word atoms. He was a philosopher. He didn't do any experimentation at all. Well, the next guy we looked at was Lavoisier. Lavoisier loved to study combustion. And he was the first scientist who actually measured the mass at the beginning and at the end of the experiment. And he actually came up with the law of conservation of matter. Law of conservation of matter. Here's the first thing you should know. That if you start with 5 grams, you're going to wind up with 5 grams. If you start with 6 grams of A and 5 grams of B, you're going to wind up with 11 grams of C. Okay? Matter cannot be created or destroyed. That was Lavoisier. The third guy we looked at was Proust. Proust came up with the law of constant composition or definite proportions. This is the guy who said compounds, in essence, all have a formula. Okay? Water is always H2O. Now, he didn't know that these were the atoms making it up, okay, that it was exactly in 2 to 1, but he knew that the mass was always 88.8% oxygen by mass, and it was always 11.2% hydrogen by mass. From this, we're going to realize that all atoms have a certain kind of weight associated with them. Okay? It doesn't matter where you get the sample of water from, it's always in this mass by ratio. Okay? So after Proust, we then went to John Dalton, the father of modern atomic theory. Now this is what he said. All elements are composed of atoms which are small and indivisible. He thought they were just like small little round marbles. 2, all atoms of an element have the same mass. 3, atoms of different elements have different masses. And 4, compounds are formed by the joining of 2 or more elements in a definite small whole ratio. Now, we know that his stuff was not correct because atoms can be divided up into electrons, protons, neutrons, and smaller things like that. We know that not every single atom of carbon has a weight of 12 grams. There are isotopes of carbon. So there's such a thing as carbon-12, there's such a thing as carbon-14. But we also know then that not all atoms of different elements have different masses. That's not making sense, is it? Okay? But according to Dalton, nitrogen could never have the same mass as carbon, which isn't true because nitrogen can be nitrogen-14, and then there's carbon-14. Okay? But it's good just to see what he had to say as he was studying this information. Now, after this, we went to J.J. Thomson. Number 5, J.J. Thomson. He's the guy who studied the cathode ray tube and the cathode rays. He discovered the electron. Remember? He discovered the electron. He found that thin beam of particles got attracted to the positive end of the magnet. So he's the guy who came up with the fact that there's an electron, and his model is called plum pudding. Remember plum pudding? Plum pudding is you have this pudding in here that has a positive charge, and inside of it are little electrons that have negative charge associated with them. That's J.J. Thomson. After J.J. Thomson came Robert Millikan. Robert Millikan did the famous oil drop experiment, and he was the person who was able to suspend the oil droplets by exposing them to ionizing radiation, and each of the droplets had a charge associated with it. It was Millikan who found the charge of an electron. And when he found the charge, he was then also able to calculate the mass of an electron. Remember, the mass of an electron is negligible. It is so small, it's hardly even worth considering. Okay? Now, after Robert Millikan, we're going to go to Rutherford. Rutherford was the scientist who shot alpha particles through gold foil. Remember what happened? Most of the alpha particles went through with little or no deflection, but every once in a while they hit something and bounced back. Remember that experiment? And then they hit something and then they got deflected. Some of them passed through. In fact, the majority of them passed through. But every once in a while they hit something in the gold foil. It was Rutherford who found the nucleus. He determined that the nucleus had a positive charge, okay? Most of the mass was there, and it was very dense. So he's the one who found the nucleus. So remember, nucleus, small, dense, positively charged. But the majority of the atoms, since the majority of the alpha particles went through, the majority of the atom is empty space. Remember we said that if this dot way over here was an electron, or excuse me, a nucleus, where would the closest electron be? A football field away. A football field away. And all of this would be empty space. That's why the majority of the alpha particles went through. Now let's go to our last guy that we're going to be looking at, and that is Bohr. Bohr came up with the planetary model. He's the guy who said, electrons travel around the nucleus like planets travel around the sun. They go in set orbits, okay? He was the guy who said, n equals 1, 2 electrons. Round and around and around and around and around. N equals 2, 8 electrons. Okay? Doesn't this look like the solar system? N equals 3, 18 electrons. Okay? So here's Bohr. Now he called his not 1, 2, 3, but he called them K, L, M, N, O, P. But we just make it now N equals 1, N equals 2, N equals 3, N equals 4. Okay? Now he also found out that certain elements release energy in the form of light when they're exposed to different types of energy. Remember this? Okay, atoms can be in something called ground state. That's when all of the electrons are in the lowest energy level available. But if they absorb energy through heat, electricity, whatever, the atom can go to something called excited state. Excited state is when an electron absorbs energy and jumps up to a higher energy level. But it can't stay there indefinitely. And so that electron is going to lose energy, and when it loses energy, it gives off that energy in the form of light. Remember? When is the color of the light produced? It's produced when the electron goes from a higher energy level to a lower energy level. Who has the most energy? Purple. Okay? Purple.